An LED has the following optimum operating characteristics. The current is 20 milliamps when the voltage is 1.8 volts. Determine the value of the current limiting resistor if the current through the diode is to be limited to 20 milliamps when powered by a 6-volt battery. Okay, so this looks like a different sort of a problem. It's actually really not. So what we have 6 volts in our circuit. We need, well, we've got 1.8 volts going across our across our LED. So we need to work out the value of this resistor. If the current is 20 milliamps, we want to know the resistance of our resistor here. Okay? So, a couple of things we do know. We know that the current in the resistor is 20 milliamps because it's the same the whole way through a series circuit. So our current going through here must be 20 milliamps. What is the voltage in that resistor? 4.2. How do you know? Good. We've got 6 volts beginning. We use up 1.8 volts here, so there's 4.2 volts that must be used in our resistor. Good. And from Ohm's law, again, Ohm's law, keep coming back to it. Our resistance is equal to voltage over current, 4.2 divided by 0.02. The resistance in there, I get 210 ohms. Yes, you do. So that's why I've got my current up here. So yeah, be careful. When you're doing these equations, it's always best to convert into amps and volts, not milliamps or millivolts. So our current here is 20 milliamps. I put the current straight away into amps. 20 milliamps is 0.02 amps. If you don't do that, if you put 20 down here, you're going to get the wrong number. So before you do any maths with this stuff, get it into your SI units. Get it into amps, get it into volts, get it into ohms.